Well, Mrs. Vinehart, it would seem that you have some information that we would like to know. The question is, will you do it the easy way or the hard way? The decision is yours. It makes no difference to me. We will get the information we want at any rate. Now, am I going to have to do this the hard way? Or will you tell me about kinetic and potential energy?
Of course I'll tell you about kinetic and potential energy. There's an awesome video. It's just over there.
Good.
Look, here it comes now.
Oh, good.
You realize my hat? Oh, that's not my hat.
Let's talk about energy. Energy is the ability to do work, cause change, such as moving one object some distance.
Everybody's been on a roller coaster, or at least seen one. Roller coasters are classic examples of potential and kinetic energy. Some people get confused when they hear the words potential and kinetic. You might question where one begins and the other ends. Potential and kinetic energy are blown out of proportion into confusing, complicated topics, but it really all comes down to two definitions.
Potential energy is energy that is being stored and is not in motion.
Kinetic energy is simply the opposite of potential energy.
Kinetic energy is energy that is being released and is in motion. Now we're going to do a lab on potential and kinetic energy. When I hold the bat, I have potential energy, but when I swing it at Brian's head, I will gain kinetic energy. Ah! Kinetic energy!
Oh.
Yeah. Hi there, how you... Ah! Kinetic energy! What are you... Oh! Potential energy and hurtful kinetic energy. La 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 la. Ah! Kinetic energy.
This brick has potential energy due to its height.
Ah! The law of the conservation of energy states that no energy can be destroyed. That means that no matter what you do with anything, you're not going to lessen its energy. Here to help me explain the conservation of energy is a small droid that my grandparents bought me from Sky Mall when I was 10 years old. R2-D2. Hey R2, explain the law of the conservation of energy. Yeah, that was just nonsense. Now that you understand the basics of energy, you can move on to the more important types of energy, like convection and conduction. Thank you, Miss Reinhardt. This video was very helpful. I understand potential and kinetic energy very well now. But I have more question for you. Tell me about convection current.
I won't tell you anything.
Well, perhaps we should ask your comrade. Wake up! Wake up, I say! Wake up! Ah! I'm afraid that I used to be quite confused on the convection current. You will tell me more.
I can't tell you more.
Then you die.
No, I can show you. If you just let my comrade go, she'll do it in the lab.
This lab sounds quite helpful. We will give it a go. Untie her.
Sir, you do realize her hands were never tied, right? I mean, she did kick you.
Yeah, you never tied my hands.
Yes, this hurts very much.
Convection currents are currents caused by uneven heating, like in a pot of boiling water. When the water at the bottom gets heated up, it becomes less dense and rises to the surface. The cooler water at the top will rush down to fill its place, and the cycle will repeat, causing circular currents.
1.
With the information we have provided you with, what hypothesis can you draw from about the motion of the oatmeal in the boiling water? Here's a lab that can show you an example of convection currents. What we'll need is a glass bowl and some oatmeal. Fill the glass bowl with water. Place the bowl on the stove and turn up the heat. Then wait for the water to boil. When the water is boiling or near boiling, add in the oatmeal. You should be able to see it swirling around inside the pot due to the convection currents, which are caused by the warm water at the bottom of the bowl rising to the top and the cooler water at the top going down to fill in the place of the hot water. Well, hotter water. What conclusions can you draw from this lab, and how can you apply it to your everyday life?
Yet another misconception about convection currents is about boiling water. Some people think that boiling water is colder at the top, or really any heated water, because of the fact that it's touching the air, which is cooler. That's not true at all. Now that you understand why the convection current works, you understand that the cooler water will be at the top, and the warmer water will be at the bottom. That's why it's colder at the top, not because it's touching something cooler than it. Conduction means that different materials absorb heat or energy at different speeds.
That means that some materials absorb heat and energy faster than other materials.
We're going to show you that different materials can conduct heat at different rates. We have a wooden spoon, a plastic spoon, a rubber spoon, and a metal spoon. Which spoon can you hypothesize will take the longest or shortest time to conduct the heat and melt the butter?
We're putting butter on the handle of these spoons to show how well each of them conducts heat.
What conclusions can you draw about conduction from this lab, and how can you apply it to everyday life?
Due to the laws of conduction, sure enough, the most melted butter was on the metal, then the rubber, then the plastic, and then the wood. That makes sense because that's the order that materials will melt when conduction is applied. Here's a little misconception from the lab we just did. Some people think that wood doesn't conduct energy. That's not true. No material is incapable of conducting energy. That's just not possible. Wood is just a very slow conductor of energy. A very, very bad one. What?
I was mouthing the word bad.
Yeah,
It's
okay.
just a bad conductor,
Okay.
not a slow conductor.
Radiation is the transfer of energy by electromagnetic waves. Radiation does not require matter to transfer heat or thermal energy.
Oi! I'm O'Brien, the multicolour-haired Scotsman with a lightsaber, and I'm gonna list the types of radiation. There's alpha, and beta, and X-ray, and neutron, and electromagnetic,
You forgot gamma.
and gamma. Okay, now we're going to talk about transfer of energy for just a little bit. This is a flashlight. It converts chemical energy in the batteries to electric energy, the light. As you can see, the batteries are completely separate, but because of the metal tip, it can change the chemical energy into electric energy. So now, it becomes a useful tool that we can abuse and use against others.
Here's our guest star, Echo. Hey, Echo, here's a space alien.
One misconception that some people have about the transfer of energy is that this ice cube is making my hand cold. But that's not true. The cold isn't going into my hand. The energy or heat from my hand is going into the ice cube and therefore leaving my hand. So you could think of it as the energy is going from my hand to the ice, not from the ice to my hand. We've taught you everything we can about forces, motion, energy, and whatever else you happen to get from this video. Thanks for watching.
Hi! This isn't a red sock, this is a blue sock. And it's not even blue, it's teal.
Am I the only sane person in this group?
Blast! This is an impossible puzzle!